To begin with, the SmartOS is designed to operate on a single button that allows that any upgrade in the future is made. We don't have to rely on several kind of buttons or several different menus. So one hardware is for all the versions. So right now we were going to start. We will press until we heard the pip and we release, and then we see North. Then this is the version of the OS and the language, and also the serial number and the version of the PCB plate, that is the motherboard. When we enter, we see two lines. The first shows, firstly here on the left, this is the operation mode of the receiver at this moment. This mode is the same that the receiver had the last time we started. Let me stress this for you. We will go into detail of every configuration level, but once it's done, you do not need to do it every time. You do not need a software to do it either, and every time you start, the receiver is ready to go. Right now the receiver is set as a base UHF transmitting radio and is ready to transmit from this moment on. Okay, so we will review every detail so you know how to do it. However, it's not needed every time. It's just on and go. Okay, so the first part is the mode that is base UHF, is transmitting by UHF. We will go into detail on every mode and its configuration. Here we see that we have int. In this place we are shown the solution that the receiver has in that moment. On the base, as there is no solution, we just see that it's transmitting. Then we have the battery that is here. Right now it's at 85%, and when it's charging, it shows an icon that is charging. And here we see N stands for Napstar, that is GPS, then G is GLONASS, C is Compass, a Chinese system, and here we see an icon that is the radio. When in this part we know if we are using UHF radio or GPRS for communication, or else that can be like in recording or serial. Then here we have a space that is not used now. When we have communication, we will see TX when it's sending the communication and RX when we are receiving the communication by any means. So to enter the configuration menu when we need it, we press the button 3 seconds and we enter to the configuration mode. In this mode, we see a few sub-menus that we show. The receiver mode is to set up the operation mode that will have the receiver. Then we have the UHF channel. When we use UHF, then we can set up here the channel for receiver, no software needed, and also for transmitting. So both base and rubber have to have the same channel. And also, if we select the channels here, we are matching the channels of the Pacific Crest by standard. So using an external Pacific Crest is not needed to set up any further channel. The receiver setup will allow us to set up a little things that we can fix, like the sound and display, without needed of external PDA or software. And settings by app are several features that we can configure by software, like the course station, the phone connection, etc. And this will allow us to operate without any kind of driver on any software. Then is near native, means that you can perhaps use Google Maps on a PC with Linux and it will work. So you don't need any special driver for the SmaRTK. Here we have the dilution of precision, that is the famous VDOP, PDOP, HDOP that we show in real time. In any kind of solution we have, the accuracy that our receiver has. And the quit menu that will give you lead us to the first one, that is the operation menu. And last is for switching off. So we will select another mode, for you to see how easy it is. We will enter receiver mode. So inside this submenu, we see base UHF internal 2 watts, that is the mode we already have. So 2 watts means that we are using the internal UHF module transmitting at 2 watts, that is for short distances like 3-5 kilometers, with a simple antenna for short operation, a little terrain or a road section, when we do not want to set up everything just for a short while. Then we have another mode that is base UHF external 0.5 watts, that is when we are going to set up an external amplifier that will raise the power to 15 or 20, 45 watts for long distance, like say 30 kilometers if we have enough Ppf. The base UHF external will drain the battery because it's using the internal radio, so it's recommended that we connect an external power source to the receiver all the time, just like the external radio. And the base serial is to connect an external radio like the Pacific Crest or any other brand through the serial port. Then we set the channel outside in the radio and the rover will just share the same channel, and we will see how to do that. Then we have Ppf recordings for post-processing static. We can do several kinds of post-process like fast static and semi-kinematic that we can use for in the post-processing systems in RINEX. So, to configure a rover network, for Ppf recording, we can use it for doing post-processing static, but we can also do fast static or semi-kinematic. And this will download data that we can record with the internal 1 giga memory, several weeks of data, and download it as RINEX and then post-process in your favorite software or ours. Then we have the rover network that is basically a rover straight to course. In this mode, the UHF radio switches off and we start the GPRS connection for mobile networks and connects to the course and then receives the correction from the course. In the case of the rover autocaster, that is a special North mode, is similar to the rover network, but in this case, instead of connected to a course, we connect to another SmartTK or SmartOS based receiver, and we can get this connection by GPRS as well without using UHF. In this case, then we have a base and a rover connected by GPRS only. That is very stable connection and is very simple to use. If you have mobile coverage, it's far better than using UHF that is not dependent on the Ppf. We have the rover UHF that is the most used in Latin America, Africa and South Asia. That is when the radio transmits by UHF, then we have the rover that internally uses the radio. Our UHF radio in SmaRTK has a very broad channel from 410 to 470, so we can cover all the world. Base autocaster is the said mode when we transmit by GPRS the corrections, and we will go into detail. So now we will set rover UHF. And we quit. Then we see that the mode changed to rover UHF, says NA, that is not available because we are under the roof, so we have no satellite signals coming. And this mode, when we have SBAS satellites, then we will change to SB to indicate this. PO is when we have position and not even S-bus, so there is no DGPS. Then FL will mean that is in float mode, and then an FX will mean that is in fixed mode, that is totally RTK accuracy and should be around 8 millimeters or less. Then we have the battery, as we said, and in this case we are not receiving data, of course, but if we were receiving data from a base, that we will see the example in another video, we will see here an RX that is receiving. Okay, so if we shut off this receiver in this mode that is already set, and we tomorrow turn it on again, we will enter directly to the rover network, rover UHF mode, and we are ready to go. We do not have to configure nothing, never, not even in the controller software. The rover is ready, will begin to receive satellite signals, and as well will receive the UHF corrections, and as soon as has a fixed mode will be shown on the display, and the data will be, of course, millimetric. So we can use any software that accepts NEMA, our top view or Carson SorbC, or any chart plotter on PC or Linux or Android or whatever medium you want, and it will have accuracy of millimeter at any time, no matter the driver you use. Okay, so we will enter here and see the other menus. So the receiver mode, we already been there. We have the UHF channel. If we enter here, we are able to set the channel directly without using software. We have the 45, 40, 450, 470 range that is the most used now. These were the presets. If we enter here, we are set on the channel 15, that is 460. This is our preferred channel because it's the central in our antennas of 460, and it's proven that this frequency is the longest to run on UHF. However, it depends on the country, you may have to change this channel. So let's do it. We'll go enter here. We select, we have, this is a special range basically for Europe, and we have 410, 430, 430, 50, 450, 70. So we can enter here and change the channel to 00, that is 460.0125. This channel corresponds to the factory preset of Pacific Crest. So if you set in a standard Pacific Crest radio, PDL, ADL, the O channel on the American frequency, you will have the 4C6.0125, and there's nothing else to do. So you can communicate along with them. Be sure that the radios are always in transparent mode, that is our standard transparent, and the channels are the same. So this set, we can see the receiver setup. We enter to this menu, and we have some things that we can do straight from the system. The mass angle, we can enter here. We have preset we made in another example of 15 degrees, but we can change it, let's say, to 10. And we set. Now we save and we'll stay there forever. Then, sorry, I will go back to the same menu to see the others. So the mass angle, then we can have the display set up. We can have auto off in 10 minutes, always on, or 1 minute. This display is not needed to be seen all the time, because after you are working with your PDA, basically it's okay to be off. So normally we can have it in 1 minute while you are starting to get to know with the SmaRTK. You can use 10 minutes, and always on is for special purposes like scientific purposes or recording or bass, that is power from outside. But usually you can set it in 1 minute, and if you need to see it for any reason, just press 1 second and it will display for 1 minute more and then switch off automatically. Always will be there. And we will set it. We enter again to see the other menus. We have sound. The sound we have is a beeping sound that will indicate if the receiver is vertical or not. So we can turn it on or off. It will not beep all the time. The receiver has to be in rubber mode, GPRS or UHF, and have at least float solution or fixed. If you are in fixed, then if the receiver is vertical, it will beep. How we know it's vertical? Let's go to the last menu, that's tilt. So internally we have a sensor that is a 3D sensor that works similar to a total station compensator. So let's say that the receiver is a little off and we see the variation in XY. We return into the position, okay? And we see that it's a little off. So we press again, okay, short, and set 0. It's very sensitive, so don't be scared. If you are using a tree brag with tripod, then we'll be okay. So you press here, and it's done. We will enter again for the last menu. That is the Ppf recording interval. So in this mode, we are ready to record at the set interval for post-processing. So let's say we can set 1 second, or 5 seconds, or 15 seconds, or 30 seconds. In 1 second recording interval, the data is so little that 1 giga, that is the standard, is more than enough for several weeks. However, you can upgrade this memory by a simple SD card. The next menu is a special menu, that is the settings by app. These are the few parameters that we can set by software, external software, not the controller software, but ours. We have a version for Android, one for Windows Mobile, and another for Windows PC, that you can set up by using the Bluetooth, all the parameters that you need to connect the cores, to set transmitting base, and others that we can see now, like the phone network. So these settings by app are made only when we are inside this menu. Then the Bluetooth port is open to receive the signals, to avoid that a misconfiguration is sent when we are in another mode by accident. So only in this menu, when we can see in real time this configuration, and we will go into detail on other videos, we can set up these details. So here we have the auto base. In this mode, when we are in a UHF or Autocaster base modes, then the latitude and longitude that we get from the first fixed position of this GPS will be began broadcasting to the rover as correction, and the rover will have the chance to use it as it is, or use the correction by rover on the software like Carson or TopView. Several topographic or surveying software had it. So you can do a millimetric correction only with the autobase. So it's very fast. But in case that we have another software, or we have a very fixed point that we are using every time, then we can set this parameter to a known latitude and known longitude, and we can enter here in as degree data. So the base will transmit with this data, and the rover will be already corrected at any moment. Here's the longitude, and we can also change the protocol. Of course, nowadays the best is RTCM3 X, because there are several versions. But some older receivers of other brands may use RTCM2 for some reason, or we need to connect to a course that is different. So in the case of the base, we can change this protocol. The rover is not needed because the rover recognizes any automatically. So we can put RTCM3, RTCM2, CRM, or CRM Plus. This is made by software. Here we have the Autocaster IP, that is our server, autocaster.net, but however you can have your own Autocaster server, and it will be configured here. And to operate, it has two ports. One that is for sending the data, and one that is for receiving the data. It's very simple to set up. And for the course, we have also a place for the IP address, for the transmission port from the course, the user, and the password. These are set by software, and then the stream is also selected in our app. When you connect to the course, these streams are retrieved from the server, and you can feed this directly to the server. So let's say that you have set your receiver to operate as a rover with course. When you start, all the data is already recorded onto your rover, and you don't need to set up nothing from the PDA, and you are straight to connect and work to fix. Then you can use your PDA and operate it, but it's not needed at all. You are straight away to work since you start the receiver, because it's already set internally. And that's all. This mode, remember, is when you are inside the setting by app mode, the Bluetooth port is open and you can send the configuration only here. If you are not inside this menu, you cannot send the data. Then we have the dilution of precision. We enter here. We can see the PDOP, HDOP, and VDOP real time. And we have the straight from the receiver accuracy settings. And it's just for viewing when you have satellites. Then we can quit the menu. And we will be in the settings that we set, with the UHF channel we set and the rover. And when we finish the work, we'll go to the same menu. We go to the last one, that's power off. And we switch off. And that's all for the SmartOS introduction video. We will go into detail to every one of the menus and the settings for specific purposes, and how to set up the accessories on the receivers. Thank you.